So good morning students. So today we are going to start lecture number 12 in case of kinetic theory of gases. Okay. So I hope you are practiced last previous class problems and all. If you are not practicing those problems means it will be difficult for you. So please practice those problems. Okay. So coming towards next question. So next question stands as, at what temperature is the root mean square speed of oxygen atom equal to the root mean square speed of helium gas atom at minus 10 degree Celsius. So given that atomic mass of oxygen is 32, next atomic mass of helium, this value is given as value 4. Okay. Clear? Okay. Will you try for this problem like previous problem only, but here one formula you should have to remember that VRMS is nothing but what? Root of 3 PV divided by M. Okay. So based on that formula you are going to solve this problem. So shall I write that formula here? Take two formulas for two gas molecules and take the ratio. So VRMS value is nothing but root of 3 PV divided by what? M. Will you calculate? In denominator that is capital M. Okay. Calculating. Okay. Shall I proceed? Listen. So here also in this question also they are asking about at what temperature, okay, is the root mean square of oxygen atom is equal to root mean square of helium atom. So you should have to calculate what initially RMS of oxygen, RMS of helium, and you should have to equate related to their temperature. Here one side temperature given, another side they are asking what is the value for temperature, and M values they had given here. Okay, in most of the question M value not given, but in this question you have been provided with what? M value. M is nothing but what? Atomic mass. Shall I erase this part? Okay. Now listen. Formula we are having V RMS is equal to root of 3 PV divided by M. Okay, or we can write this as, for ideal gas, PV value can be written as what? RT for 1 mole. 3 RT divided by what? M. Clear? Now, let us assume that VRMS 1, okay, this is nothing but root mean square velocity for first gas, that is nothing but what? Oxygen given to us. Okay. Next, VRMS 2 is nothing but what? Root mean square velocity for second gas, that is nothing but which gas they had given? Helium gas. Okay. Here temperature asking, here temperature given as minus 10 degree Celsius. Okay. Now, we should have to calculate with respect to formula. So now VRMS 1 will become what? VRMS 1 will stands as what? VRMS 1 is nothing but what? Formula is 3RT divided by M. So we are going to write 3R value is constant only, because R is gas constant. Multiplication of 3 into R stands as what? Again constant value only. But temperature value will be changing, M value will be changing. So for oxygen treating as first gas, I will be writing T1 M1. So this value will stand as 3R T1 by M1. Clear till this point? Okay. Now, second one, we are having helium. So root of 3R T2 by M2. Clear? Now, take the ratios. Otherwise, you can equate also. Listen. If I take the ratios means VRMS 1 as well as VRMS 2. Okay. Listen, how we can do this one. VRMS 1 divided by VRMS 2 will be equal to root of 3R T1 by M1 whole divided by root of 3R T2 by M2. From here 3R will get cancelled. Clear? Now, here what all the things are remaining inside the root? Correctly you should have to write in numerator root T1 by M1, in denominator root M2 by T2 means root of T1 by M1, okay, root of M2 by T2. Clear? Getting? Okay. Now, we should have to substitute the values and we should have to calculate now. Listen. This value, okay, this part, how we can write? Listen, shall I erase this part completely? Okay. This step we need. Okay. VRMS 1 by VRMS 2 will be equal to root of T1 M2 by M1 T2. Clear? Now, T1 value, they are asking us. T1 we don't know. Okay. T2 value given as what? Minus 10 degrees Celsius. Degree Celsius to Kelvin. Minus 10 degrees Celsius plus 273 will give rise to 263 Kelvin. M1, M2 values given. M1 is for oxygen. M2 is for helium. For oxygen, Value given as 32, no? Okay. And this value given as what? 4. And VRMS1 by VRMS2 both are equal, they will get cancelled. Okay, these two will get cancelled. So left hand side 1 is remaining. Left hand side 1 is remaining. In right hand side, what all the things remaining? Inside the root we are having T1, M2 is nothing but 4, M1 is nothing but 32, T2 we are having 263. Clear? Getting? Okay. If we square both the sides, means squaring of this is 1 equal to, sorry, okay, 1 is equal to root of T1 into 4 divided by 32, 263. Squaring on both sides, what we are going to get? 1 square is nothing but 1. Here if I square means I am going to get T1 into 4 divided by 32 into 263. Okay. Okay. 1 is equal to, listen, if I separate T1 means T1 is equal to 1 into 32 into 263. 32 into 263 divided by what? 4. Clear? So if I solve this one means what value we are going to get? Four ones are 4 eights are. Okay, 263 times of 8. So value will be almost near to 2000. $2104. This is nothing but what? T1. It is in Kelvin. Okay. Understood this question? So if they are giving comparison means note down the characteristics and take the ratio. Okay. Shall we go to next part? So 2-3 times I had erased the board, but while noting down correctly you should have to note down. Okay. Shall we go to next problem? Next. Calculate VRMS of oxygen molecule at 27 degree Celsius. Atomic weight of oxygen is 16. Okay, given that atomic weight is 16. Okay. Yes, how we can proceed with this problem? Can anyone try? Can anyone tell me how we can proceed? Directly they are asking what VRMS value. Okay. And they had given what? Temperature as 27 degree Celsius. Okay. You can note down the values, what all the things they had given. Given Temperature value 27 degrees Celsius given. T is equal to what? T is equal to 27 degrees Celsius, which stands for 27 plus 273, which is nothing but 300 Kelvin. Okay. Next. Atomic weight of oxygen given. Okay, if you want to note down, otherwise leave it. Next. So in solution, better you note it down. Atomic weight of oxygen is equal to 16. Next. M value, capital M value. (32 gram per mole). For oxygen, value will be this one. So I can write it as 32. If I want to convert it into kgs, means 32 into 10 to the power of minus 3 kg per mole. Okay. Next. This is known as what? Molecular weight. Molecular weight. Okay. Now, again, next what they had given? No, only this much they had given. What is the formula for VRMS now? Formula for VRMS is nothing but what? Just now I had told you, that is nothing but root of 3 PV by M, or we can write it as 3 RT divided by M, because here pressure value is not given to you. That's why change it for 3 RT divided by what? M. RT by M. R is nothing but what? Universal gas constant. Value stands for 8.31. For R, value is nothing but 8.31. T value already here I had written 300. M value will be 32 into 10 to the power of minus 3. So if you calculate this much, means VRMS, where I can write VRMS is equal to root of 3 into 8.31 into temperature value 300 whole divided by capital M value 32 into 10 to the power of minus 3. So VRMS will comes out to be how much? 3 into 8.31 into 300 divided by 32 divided by 10 to the power of minus 3, complete value inside the root, means this value nearly we are going to get. So value will turn out to be 483 meters per second. Okay. Everybody got this value? VRMS value. Okay. Shall we go to next problem? So here in this problem what they had asked, VRMS for oxygen molecule at 27 degree Celsius. So we had calculated VRMS value for oxygen molecule and temperature was at 27 degree Celsius. Okay. Shall I erase this part? Next question. The root mean square speed of oxygen molecule root mean square speed of oxygen molecule in bracket O2 at a certain temperature T is V. Okay, RMS speed of oxygen molecule at some temperature T is value is V. Next, if the temperature is doubled, if temperature is doubled and oxygen gas dissociates into oxygen, atomic oxygen, what is the speed of atomic oxygen? If this oxygen molecule will be dissociates into atomic oxygen, then what is the speed of atomic oxygen they are asking. So we know that VRMS value is nothing but water, root of 3 RT divided by M. Correct, no? Now, when T is equal to, that means new temperature is equal to 2 times of initial temperature, then what will happen for M? M will become M divided by 2, okay, which is nothing but atomic oxygen. So when T becomes 2 times of T, M becomes M by 2. So these factors we should have to substitute here now. So VRMS value will be equal to what we are going to get here, 3 as it is, okay, R value as it is, later we can check about that, T value 2 times of T divided by M value is M by 2. Simplify this one, what value you are going to get, note it down. Now here this denominator of denominator will come to numerator, 2 into 2 into 3. 2 2s are 4, 4 3s are 12. 12 RT divided by M. Correct, na? This value is nothing but what? 12 RT divided by what? M. Or 12 can be written as what? 4 into 3 RT divided by M. 4 we can take outside the root, 2 times of 3 RT by M. 3 RT by M is the thing but what? VRMS. That's why it will become 2 times of VRMS. Okay. So if temperature, speed of the atomic oxygen will be doubled if temperature is doubled. Okay. Understanding? Clear? They had not specified about temperature here. T value not specific numerical number they had not given. Only value they had given, that value is nothing but what? T. That at some temperature T, they are telling that value is V. Okay. Root mean square speed of oxygen molecule at some temperature T is, value is nothing but what? V. Okay. And next they are telling if temperature value is doubled means what will happen for VRMS value. That means this is nothing but VRMS value initial case. Then when temperature is doubled, then what will happen for VRMS? That they are asking. So VRMS is equal to root of 3 RT by M. Already we know this formula. Number of times we had written this formula. Okay. 3 PV by M. Okay, PV is equal to nRT for 1 mole of gas, 3 RT divided by M. And next, here we had substituted the values. 3 are when temperature becomes 2 times of the temperature. This is for M means complete atomic mass of oxygen molecule. Okay. Now it is becoming atomic oxygen means M value will change to half of that M value, which is nothing but what? M divided by 2. That M by 2 here I had substituted. So finally we are going to get 3R2T divided by M by 2. This 2 will come to numerator, 2 into 3 into 2. Okay, or 2 into 2 into 3, which is nothing but 12. 12RT divided by M. Or we can write 12RT as 4 into 3RT. This is nothing but what? M. Okay. So 4 we can take outside the root. I can write 2 times of root of 3RT divided by M, or 2 times of V RMS. Clear? Okay. If same mass of gas is there and they had given PV diagram means, okay, for two temperatures, one temperature is this temperature, they are telling T1, this temperature they are telling T2. Okay, they make you 4 options here. Okay, among 4 options, which will be the correct option for this? Can you tell me? For same gas, same amount of gas, when two different temperatures, at two different temperatures, the values if we record and plot P versus V means, among these two, T1 and T2, T1 is greater than T2, or T2 is greater than T1, or T1 equal to T2, or none of the above. Okay, like this if they are asking the question means. What is the correct option over here? Among T1 and T2, which one will be having greater temperature basically? Basically T1 will be having what? Maximum temperature. Correct? Huh? I discussed this in, I hope, lecture number 2nd or 3rd one. Okay. So temperature value will be directly proportional to what? P into V. Okay. Because we know that PV is equal to nRT. Correct? Now we know that PV is equal to nRT. If I separate for temperature means T is equal to what we can write? PV by nR. Okay. So temperature is proportional to PV, and PV is greater than T1 and it is less than T2 means therefore T1 value will be greater than T2 value. So like this also they may ask question. If they are asking like these types of question means you should have to answer these types of questions also. Okay. And if they are talking about average kinetic energy means, average kinetic energy of the gas molecule, okay, is directly proportional to, okay, average kinetic energy. Average kinetic energy is proportional to which quantity if they are asking means. What will be your answer? Average kinetic energy value is proportional to which quantity? Always remember, if temperature increases, average kinetic energy value increases. So average kinetic energy of the gas molecule is directly proportional to temperature of the gas. This is not question mark value. Now I am going to write answer here. This answer stands for average kinetic energy value is directly proportional to temperature of gas molecule. Clear? So keep studying. Again we will meet in our next class. Thank you.